have discussed linear programming problem. Then it's means how to write a linear programming problem. Next one is what? After formulation of the linear programming problem, how to solve the linear programming problem. Suppose last class we identify which one is objective function, which are the constraint or etc. Okay. Next one is for solving linear programming problem, there are some methods. But before these methods, we need some definition or some. So first one, I have given the note in your WhatsApp group. What is convex set? Okay. So convex set is what? A set of points is said to be convex if for any 2 points in the set, the line segment joining these 2 points is also in the set. Means what? Suppose if you draw one circle, okay, so in circle you just give 2 3 points like this, okay. So when we draw these points, these 2 points lies in the circle, then this is called the convex set. Okay, means whole the line belongs to the circle, belongs to suppose circle or square or etc. If line is outside the circle, any portion of the line is outside the circular region, then this is called the non-convex set. So you will see I have given the diagram also, which one is convex set and which one is the non-convex set. Okay. Next one, I have given extreme point of a convex set. So extreme point of a convex set means what? A point, suppose you consider x in a convex set is called an extreme point if x cannot be expressed as a convex combination of two distinct points x1, x2 in C. Obviously, an extreme point is boundary point of the set, and it is important to note that all the boundary points of convex set are not necessarily extreme points. So means what? Extreme point means what? Roughly we remember this one will be what? When some objective function is given and constraints are given. So after solving this constraint, we get the values of say x1 or x2 or x and y. Okay, anyone. When we substitute this value in z means objective function, then we get means what? We get the values, and here if objective function is maximum, then maximum value is called the means what? Maximum value, at which point this gives us the maximum value, then this point is called the extreme point. And next means what? How to formulate the linear programming problem. So if you see, I have given one problem. Have you seen in your WhatsApp group? I have given one problem given example I have given. So have you seen, Arvas? The current one, today I have sent this one. Yes. Okay. Yes, a manufacturer produces. Okay, so all of you see this question. Okay, all of you find out this one. A manufacturer produces two types of toys, that is A and B. Each toy of type A requires 4 hours of molding and 2 hours of polishing, whereas each toy of type B requires 3 hours of molding, 5 hours of polishing. Molder works for 80 hours in a week and polisher works for 180 hours in a week. Profit on a toy of type A is rupees 3 and on a toy of type B is rupees 4. In what way manufacturer allocates his production capacity for two types of toys so that he make the maximum profit per week? Okay, so first you see here manufacturer produces two types of toys. Here types of toys are what? Toy type A and toy type B. For toy type A, we require there are two operations. Operations are what? One is molding and one is polishing. So for toy type A require 4 hours for molding and 2 hours for polishing. Another toy of type B requires 3 hours of molding and 5 hours of polishing. Okay, toy type A means one quality, A type quality, another is B type quality. Okay, next here given you see molder works for 80 hours in a week. Okay, and polisher here operations are what? Molder is one operation and polishing is another operation. So for polishing 180 hours in a week. So here this is imaginary 180 hours, this is just given, not possible. Okay, just imaginary number taken 180 hours. Okay, next you can underline this one. Profit on a toy type A is rupees 3 and on a toy of type B is 4. Okay, next, in what way the manufacturer allocates his production capacity for the two types of toys so that he may make the maximum profit per week? Okay, so here first finding the solution, for finding the solution first we shall formulate, means we make the linear programming problem, means what? We formulation of the problem. Formulation of the problem means what? We first we need what? Objective function, and next we need what? Constraint. Constraints means what? How to constraint? There will be some restriction and there will be an algebraic relation, means if you consider x1 x2 variable, what will be its relation with the operation here toys of type A, and here poly operations are molding and polishing. Okay, so here our first aim is what? Our first aim to find out what will be its objective function, what are its constraints. Clear? Arbas, clear? Okay. So you go to the solution first. Okay, so here first you see this problem will be maximization problem or minimization problem. Anybody? This problem will be maximization or minimization problem. Today
Maximize.
I have yes, good, Shankana. This one will be maximization problem. Okay, so all of you see today's I have sent one means sent one PDF. You see the problem. A manufacturer produces two types of toys, type A and B. All of you see this question. So here profit is given, so the problem is of maximization problem. Okay, so here how many toys? Two toys here. So we consider A type toy, there are x1 be the number of toys of type A. Okay, and x2 be the number of toys of type B. Clear? Next, here for toy of type A, profit is what? 3 for one toy. For one toy of type A, our profit is rupees 3. So what will be the profit of x1 toy of type A? 3x1. Similarly, for the profit of toy of type B, rupees is what? 4. This is given. So here how many number of toys of type B? X2. So x2 toy of type B will be what? 4x2. Okay. So here next hour is what? Total profit will be what? The total profit how we shall get? toy of type A and toy of type B. Means we consider the variable z equal to 3x1 plus 4x2. Next one will be what? You see, one toy of type A. Next, we move to the operation. Our operations are what? Molding. And another one is polishing. So, for one toy of type A on molding requires, one toy of type A on molding requires 4 hours. So, here how many toy of type A we consider? X1 toy. So, we require how many hours? 4 into X1 means 4x1 hours. Similarly, for molding of toy of type B, it requires 3 hours for one toy. Same way, X2 toy we consider type B. So this how many requires? For molding requires 3x2. On molding, total time required will be sum of these two, means 4x1 plus 3x2. Okay, so you see, this is our algebraic. Next one is what? There is some restriction given. Restriction in the question you see, molder works for 80 hours in a week. What is the meaning? Acha, our total molding time required is 4x1 plus 3x2. And next one is molder works 80 hours in a week. What is the meaning? Shankana?
The
Molder
will
works
work
it
anywhere between 80
means
hours. Will work
means
not
maximum 80 hours or
maximum 80
minimum or cannot exceed na? So cannot
hours.
exceed maximum 80 or equal to 80 or means what, maybe less. So you see, I have given here, but molder works only 80 hours in a week means what, 4x1 plus 3x2 less than or equal to 80. So you see, this relation is clear or not, less than or equal to. Oboni, 4x1 plus 3x2 less than or equal to 80.
Yes, sir.
Okay. So next one toy of type A on polishing requires 2 hours. Therefore, x1 toy of type A on polishing require what? Twice x1 hours. Twice x1 hours. Similarly, for toy of type B, polishing require 5 hours. So here how many toy you consider? X2 toy. So this one will be 5x2 hours. Next will be on polishing, total time required will be twice x1 plus 5x2 hours. On polishing, total time required equal to twice x1 plus 5x2 hours. Okay. Next, again there is some restriction for polishers. What is the restriction? Means per week they can work 180 hours. So here restriction is what? Is 180 hours. Means sum of these two less than or equal to 180. Means this is either 180 or equal to or less. Next, I have written, since the number of toys produced is non-negative, so x1 greater than or equal to 0 and x2 greater than or equal to 0. Okay. Here, what is x1 and x2? What is x1 and x2? Anuj, anybody? What is
Number
x?
Yes, sir. X
Uh,
type A.
number right.
Choose the type.
acha, Arbaz, what is x1? X1 is hmm, yes, and x2. So type B. Okay. And another name will be what? X1 and X2 are what? constant or variable? Constant or variable? X1 and X2 are constant or variable?
Constant.
Variable.
Not constant.
Variable.
How this? Yes, good. A variable. What is the name of this variable? What is the name of this variable?
Number of toys.
What is the name of this variable? Last class I have given formulation of the yes. Name of this variable is decision variable. Name of this variable is called the decision variable. Okay, so you see x1 and x2 here decision variable. Achha. I have written here x1 greater than or equal to 0, x2 greater than or equal to 0. So why this is greater than or equal to 0? Why we have not written less than 0? Suppose someone asks, why you have not written x1 less than 0 or x2 less than 0?
Production
What will
of toys
be?
can never be negative.
Yes, here x1 and x2 are the number of toys of type A and type B. So this cannot be a number, cannot be a negative production. Hence, next you see, hence the linear programming formulation of the problem is as follows. So maximize z equal to 3x1 plus 4x2 subject to the constraint 4x1 plus 3x2 less than or equal to 80 twice x1 plus 5x2 less than or equal to 180 x1 greater than or equal to 0 x2 greater than or equal to 0. Okay, next I have given one table. This is shortly I have given, this is shortly you can make this table, and from this table you can write the equation, means formulation of the problem. So here you see, here one is operation, another one is toy. So operations are what? Molding and polishing. What are the units of molding in hours? What are the units of polishing in hours? Okay, and another one is profit in hours. So here toy of type A for molding require what? 4 hours, and polishing require 2 hours, and toy of type A profit is what? 3 rupees 3. I have written 3. For toy of type B molding 3 hours, polishing 5 hours, and profit is here 4. So time available in hours, here 80 hours for molding, total molding require 80 hours. For total polishing maximum will be what? Total polishing will be what? So total polishing will be 180 hours. From here, 180 hours. So from here, we can say that 4x1, if you consider toy of type x1 number, so 4x1 plus 3x2, here restriction is what? Less than or equal to 80 hours. Similarly for polishing, twice x1 plus 5x2 less than or equal to 180 hours. And profit is what? Profit is maximization problem. So for toy of type A, we consider x1. So for one number 3 rupees, for x1 number of toys of type A, 3x1. Similarly, for B, 4 rupees, one toy of type A, profit 4. So x2 number will be 4x2. So total will be 3x1 plus 4x2. This is clear. So in this table, we can, from this table, we can formulate the linear programming problem. You see, this is clear or not? Okay. So here you see, up to this is the formulation of the linear programming problem. Okay, so next, what is our aim? Our aim to find out the values of, here unknowns are what are the unknowns, Siddharth?
X1
What
and
are the
X2.
unknowns? Yes, Ishita, x1 and x2 are the unknowns, so our aim to find out the values of x1 and x2. So you see, for solving this there are some methods. Okay, one is called graphical method and another one is called simplex method, and there are many different methods, but we usually use graphical method. And sometime we cannot solve this problem by graphical method, then we apply here algebraic method. Name of this method is called simplex method. Okay, so graphical method when fails, acha, here how many variables here present in this problem? How many variable?
Two.
Two variable, and name of this variable is called decision variable. Okay, so two variable present, so up to two variable we can apply simplex method, graphical method. Up to two variable we can solve it by graphically, we can solve. But if more than two variables are present, then we cannot use graphical method, then we apply here algebraic method. Name of this method is called simplex method. So you see, first we shall try to formulate the linear programming problem. After this we solve. There is some procedure how to. Yes. Yes. Yes, good. Uh, Algebraic method means, see, algebraic method is called simplex method. If two variables are present here, we can apply also simplex method. But if more than two variables are present, then we cannot use means graphical method. But what happen? If two variables are present, then always you will try to solve it by graphical method. Why? Because simplex method is lengthy method. Okay, there is some time consuming. So graphically you draw the graph, and from this graph we can easily demonstrate what are the values of x1, x2, and substitute in the value of z. Then we can find out what will be its, what is given maximum value or minimum value. Okay. Acha, objective function, this is objective function. So in this, after solving this problem, we get here objective function is maximize. Okay, sometime somewhere you will get minimum. Okay, so then objective function is minimum, but here objective function is maximum. And this objective function is called optimum value. Optimum means what? Either maximum or minimum. So some particular problem, this should be either maximum strictly written maximized z, or some problem strictly written minimized z. Okay, so up to this first two three problem we formulate, means how to formulate the linear programming problem. Up to two three problem we shall means three two three question how to make formulation of the linear programming problem. And after this we solve this by variable present, we shall use graphical method. If more than, then we use simplex method. Okay, those who join here in late, then you see the this I have given one PDF file I have sent in WhatsApp group, and then you will see, if any doubt then you can ask. Okay, so regarding this linear programming problem, any doubt in formulation, objective function and constraint? Any doubt, anybody? Okay, so Next class I shall discuss the another means next 2-3 problem. After this we shall solve the problem how to find out the values of x1 x2 using the appropriate method. Okay. Just response your name.
Present,
Obilaksha.
sir.